Alright, today we're going to talk about decimal dimensions and tolerances. I've just got the pages out of your book up here because I'm just going to point out some things as we go through. But the first thing we need to realize, we've been working with fractions, is what we worked with on the last lesson, but now we're going to get into talking about decimals. Using fractional tolerances are fine if we're not holding a real tight degree of accuracy. Fractional tolerance is about, it's a plus or minus 64th, which is about 16 thousandths. It's 0.0156. When we get down to where we need more or we need less tolerance on something where it can actually has to be created more accurately, we need to go to decimals. And that's what we're going to talk about today when we talk about decimals. Now, whenever we get into looking at decimals, this right here is 0.10. Now, in a mathematics world, we refer to that as 1/10. When we're talking about as machinist language, we always go out to the third decimal place. We go out to thousandths of an inch. For instance, 0.001 is 1,000th. When we come back and we start looking at 4 decimal places, we refer to this as 1/10,000th, or you might hear a machinist refer to it as a tenth. 100th is actually 0.01 in a mathematic world, but we go ahead and we just tag on an extra 0 on the end of that, and we refer to it as 10,000ths. So the basic gist of what I want you to get out of this is we go out to the third decimal place as machinists. We go out to the third decimal place and we refer to everything as thousandths of an inch. For instance, this would read 100 thousandths. This right here would read 0.010, which is 10 thousandths. This would read 0.001, which is 1,000th. And then this one here is 0.0001, which is actually 1/10. And the reason we say 1/10 is because it's 1/10 of a thousandth. Alright, hope everybody understands what I'm talking about on that. For those of you that are in fundamentals or having fundamentals right now, you'll understand that even more because we're working with that every day. When we get down and we start talking about decimal tolerances, decimal tolerances are smaller than fractional tolerances. We've talked about unspecified tolerances. When you look in your book, on your title block, we have specified tolerances. They got a block, it's called standard tolerance block. It says unless otherwise specified. This tolerance block in there means that every dimension on there that does not have a tolerance on it, you refer to that block. And we'll look at that here in just a minute. We'll come back to point-to-point dimensions. Here's what I'm talking about with standard tolerances. This block right here will always be in your title block. Okay? If I come over and I look and I see, alright, I've got a diameter 0.25 here. That means I've got a hole that's 250 thousandths in diameter. Well, what size is the tolerance on that? There's no tolerance listed in the dimension. I have to come over to my standard tolerance block, which is right here, and I look and say, alright, this is a 2-place decimal. So here I look and I say, alright, 2-place decimal plus or minus 0.01 or plus or minus 10 thousandths. So that means that this 250 can either be 250 plus 10 thousandths, which would be 260, or it could be 250 minus 10 thousandths, which is 240. That gives me my tolerance range. Actually, let's look down here. Their example is actually dealing with these location dimensions here. You've got 0.500, which is 500 thousandths, for that spacing from the edge of the part over to the center of the 120 diameter hole. Okay, I look over here. I don't have a tolerance in this. I can look over here and say, alright, I don't have a tolerance. It's a 3-place decimal. I got to come over here and find 3-place decimal. Here it is right here. 3-place decimal plus or minus 5 thousandths. So I know that this can be 505 or 495 and still be correct. Same way here. 1 inch, 3-place decimal. I look over here. I find that it could be 0.995 or it could be 1.005. They show you that right here. Now, when I come down and I actually have a specified tolerance, this is what I would mean by specified tolerance. I look right here and I realize that it's 500 thousandths plus or minus 0.005. Okay, that means I can be 505 or 495. I really think they should have used a different number here than what they had in the standard tolerance block, but you get the idea. If the dimension has a tolerance called out in it, that overrides the standard tolerance block. If it's like this, has nothing on it, you have to refer to the standard tolerance block. Now we get into dimensions like these. We talked about last time, we talked about bilateral tolerances. Bilateral tolerances go plus or minus 0.005, for instance. A unilateral tolerance only goes one direction. It could be 1.000 plus nothing minus 5. So it means you can't be on the plus side, but you can be 995. Alright, that is a unilateral tolerance. Then we get into limit tolerances. This is not a fraction. When I look at 505 over 0.495, that is not a fraction. This has the high limit up on the top, has the low limit down on the bottom. We refer to these as limit tolerances. Now, we want to get into different types of dimensioning. This type of dimensioning right here is called point-to-point dimensioning. That means I'm going to drill a hole from the edge here to the center 1 inch. And then from that hole I'm going to go 750. From that hole I'm going to go 750. From that hole I'm going to go 750, and then the next hole is going to be 750. This is point-to-point dimensioning. It means every dimension is dependent upon the one before it. There is a problem with this type of dimensioning. If we refer to a standard tolerance block, 3-place, if you recall, that's plus or minus 5 thousandths. Alright, let's say we came in and this was 1.005 when we drilled it. That's correct. Okay, so we could say, yeah, that hole's right because we're at the high side of the tolerance. It's okay. 1.005 is the location. Let's say we came in and did this next one. It was 755. Alright, we'll say, well, that's correct. So we've got 5 thousandths over on this one. Let's say we continue to be 5 thousandths over on every hole. That means 5, 10, 15, 20, 25. That means this hole, if we were at our maximum dimension on every hole, that this hole is going to be 25 thousandths off because we have what we call tolerance buildup. Okay? Point-to-point dimensioning is very dangerous because it has tolerance buildup. So you got to be careful with that. A way to get around that is to come in and do what we call baseline dimensioning or datum dimensioning. Okay? That means every hole comes off of the same edge or the same reference point. If you notice, every dimension comes off of this left end of the piece. Regardless of where this hole here is going to be placed in relation to that end, so we do not have tolerance buildup. Alright, again, you could come out of the center of a workpiece. That could actually be your datum line or your baseline. Okay, so if I want to know which dimensioning system is most likely preferred, I would say that datum or baseline dimensioning is the best because you don't have tolerance buildup. We also have what they call coordinate dimensioning or ordinate dimensioning, sometimes called this. This is the same as baseline. Everything's coming off of this end of the piece. It's just a neater way. It's just kind of more neat because it's just got the dimension coming up here on each of these center lines. It's got an extension line coming up off the center line here. And you just see it's just a nice clean way to keep your print from being cluttered. Alright, so just a little bit about the different types of dimensioning systems we do, and a little bit about decimals. For this time, go ahead and do your homework. Your homework will be for D9. Okay. I do want to call your attention to something though. Questions 4 and 10. Questions 4 and 10. They're both asking the same thing, so don't get confused when you see that. They're both going to have the same answer. Nothing wrong with the way they worded or anything like that. It's just that they're both gonna have the same answer. Number 8. Be careful when they talk about the mean length of 1.25. Don't get hung up and be thinking of diameters there. They want to actually know what is the mean length of that 1.25 plus 2 minus nothing. So that means you need to be thinking of length there. Don't be thinking of the diameter. And of course, mean is going to mean the average, the one that falls in the middle. Okay, so just to let you know, that's what you're going to be looking at for your homework. That ought to just about wrap this one up. So.